Hi everyone. I want to sorry about my connection problem, and the camera is not working right now. And my name is Ruhi. Firstly, I want to introduce myself, and after that, now I want to give you some information about the decision making lesson, as you see on the Excel. And various decision-making techniques exist to help the decision maker deal with such a decision situation. And decision situation can be divided into two classes. There are no situation where possibilities exist. Using a payout in that using and preparing this time this three plan, and the decision maker always use the payoff table in that process. Table is means of the organizing decision situation, including payoff from different decision given various states of the nature. Decision making criteria after the decision situation is organized into pay table. Several criteria are available for making the real decision. The decision criteria which will be presented in this section includes maximax, minimax, regret, and Harwich and equal probabilities, and the maximum value and the minimum value as you see on the table, and the minimum value as is shown is here, 0.4, and the maximum value is shown is here, 0.6. And the Harwich criterion is a compromise between the maximize and minimize criteria. The coefficients of optimism is a measure of the decision maker's optimism. As you can see on the decision option as selected at the node in the tree plan. When they created the tree plan, depending on the branch chosen, as you see, apartment and land. The decision maker reach probabilities node 2, 3, and 4, where one of the states of the nature will prevail and result in one of 6 possible payouts. And there is, as you see, that there is 2 options, and the decision maker invest land, and another option is that purchase apartment. And determining the best decision using a involves calculating expected outcomes value at each probabilities node. This is accomplished by starting with the final results and payments, and working backwards towards a node 1 actually. In the decision tree, yeah, it's here. And the returns are calculated at each possibilities node, and all of the possibilities is resulted in here, as you see. And these values are now shown as expected return from each of the 3 branches, as you see. All of the nodes are resulted in here. As shown in the figure, decisions are available in the first node. The first option is to buy land, and another option is to buy apartment purchasing. The cost in both cases is shown. There are 2 options available. If you are purchasing a decision making, if you are purchasing a decision as a decision making apartment, these options have minimum value of the with this minimum value, as I said, um, one as I said 0.4 with the last city of population, and another option is increase in the city population by 0.6 as you shown in here. And after that, another option is the purchase of the land. In the case of the purchase of land, yeah, is here, as you can see. And another option is that purchase of the land. In the case of purchase of the land, there is a probability condition of 0.6, which is a good option, and 0 point is a good option, but another option is that 0.4. 0.4 is the bad option, is here, the case of the worst case, as I mentioned. And that's the choice of the land condition, 0.6 payments. 0.6 payments actually, yeah, 0.6 payments. Along note of 3 and note 4 with the graph 1 equals 20 million and other ministry million, yeah, is here, equal to here. If according to all of the options, if the investor want to use the commercially as the seen in the tree plan, the probability of the population increase in that part of third decision making node is low, and the predicted as actually in that, let me show you in that here, 0.3. On the other hand, if he or she expect the result from the land, and he or she has invested in commercially, and the predicts a population increase in that region, and sees the good probability ratio as 0.7. That's it. When she or he buys land and uses it commercially, result according to third note is shown. Third note is shown actually. The result according to third note is shown considering all this. The cost of buying and land and building an apartment in the third of 40 nodes should be in the decision stage, because it has a high value in terms of probability and it will cost less. I'll finish my presentation, and because of my connection and camera problems, sorry about that.